Good morning, students. Now, in our today's discussion in optics, we are proceeding to the topic of prism. You must be remembering in our last class we have discussed the thin lens formula and combination of two thin lenses in contact. With that, the power of a lens and all we have discussed. Today I am changing the topic. Our topic is prism and we shall discuss also the refraction through a prism. But first we shall discuss the prism. Now, before I start it, I just tell you today, just now, I have sent in your WhatsApp the deleted portion of physics for this year. Due to COVID-19, you must be knowing that CBSE has reduced the syllabus. So I have sent you the reduced syllabus, that portion. Go through it. And I think the portions which have been already taught, you can once see those portions, and the portions which are not there have been deleted, you can ignore those portions. In case of any inconvenience, you may ask me or ask your physics teacher. Okay. Now, today our discussion is regarding the prism. Let us first see what is a prism. Actually, I have written here. What is a prism? Prism is wedge-shaped portion of transparent medium bounded by two plane faces inclined to each other. It is a wedge-shaped portion of a transparent medium, like this. It's a wedge-shaped portion of a transparent medium. Okay, it's made up of glass, suppose. Normally it is made up of glass. It's made up of a transparent medium. It's made up of glass. Here the prism is, and bounded by two plane faces which are inclined to each other. Now you can see, let us now discuss this figure. Very much clear. At a glance we can see this prism is actually, this prism, in according to our syllabus, we are taking the case of the equilateral prism. Okay, we are taking the case of the equilateral prism, in which the top surface DEF and the bottom surface ABC both are each is an equilateral triangle, and they are bounded by three surfaces. You look, three surfaces. What are the surfaces? BEDA. Look, the surfaces are BEDA, okay. Second surface is DACF, okay. And third surface is the front one, EFCB. You can just watch. These are the surfaces. Very clear, these two surfaces are inclined to each other. One is BEDA and another is DACF. These two are inclined to each other. These two surfaces are called the refracting surfaces. These two surfaces are known as refracting surfaces, whereas this is known as the base of the prism. Alright, and these two refracting surfaces, means I am talking about the refracting surfaces which are meeting along the line AD. Along the line AD. The line AD is called here, the line AD is called here the refracting edge. The line AD is known as the refracting edge. I hope you understand. That means, as its name is refracting surfaces, it means the refraction will be taking place through these two surfaces. I will explain how it will be. So, refraction will be taking place through these two surfaces as shown, BEDA and DACF. Alright, and base is in front of us. Normally through that the refraction will not take place. Alright, in our discussion, mainly those surfaces are known as the refracting surfaces through which the refraction will be taking place. And this angle or this angle, look, I have marked the angle, either EDF, okay, either you can say angle EDF or angle BAC. These are known as angle of the prism. What is the angle of the prism? Angle of the prism means the angle which is bounded by two refracting surfaces. The angle which is bounded by two refracting surfaces is known as the angle of the prism. Alright? That is called the angle of the prism. That we have got. Fine. This is regarding a prism. A prism looks like this. You might have seen the prism in your junior classes, or we shall see it in our practical classes. It will look like this. Now, if this prism is placed on a white sheet of paper, alright, this prism will be placed on the white sheet of paper, and it's this, that is the base which is there. One top surface and then another bottom surface. Each is an equilateral triangle, right? And other three surfaces, and altogether there are 5 surfaces. So other 3 surfaces, each is a rectangle. Each is a rectangle. Whether you take BDA, DSEF or EFCB, these all are the rectangles. So what we do, we shall place this prism on the white sheet of paper, and we take its, you can say, borderline, means we shall plot with the help of the pencil its outline of this. What we shall get? This type of the outline we shall get. We shall put the prism on the paper, we shall take the outline, so we shall get the outline of ABC. Fine. And with the help of the pin method, by putting the pin, by seeing the image, we can plot the rays. Okay, how can we plot the rays? The rays will be plotted like this. PQ is known as the, here, PQ is called the incident ray. QR is called refracted ray. And RS is known as the emergent ray. Alright, these are the name of the rays. Now this is the Q is the point of incidence on this surface, R is the point of incidence on the another surface. Here on these points Q and R, if we drop in normals from the point N1 and N2 respectively on these are the two normals. These two normals are meeting at the point O. Then what will happen? This angle will be I. Okay, this angle will be R1. Alright, this angle will be R2. Fine. And this angle will be E. Let us now see what are the things, what we are getting. Look at this. We are getting, obviously, incident ray is forming the angle I with the normal. That is called the angle of incidence. I is the angle of incidence. R1 is the angle of refraction. Now, what is R2? R2 is the angle of incidence on the second surface, second refracting surface. And E is the angle of emergence. Okay, E is called here, E is called angle of emergence. Sorry, E is called the angle of emergence. I write it here, angle of emergence. Look, and these two normals are meeting at the point O. Fine, they are meeting at the point O. Look, this is the figure. Is that all right? So this is the figure we are getting now. Suppose this PQ is produced in the same direction. Let us say PQ is the incident ray, has been produced in the same direction. Okay, let us say it is produced up to the point T. And now SR has been produced in the backward direction. It is meeting at U, suppose. Look what we are getting. I have produced PQ in the same direction and SR backward. What we are getting? We are getting an angle delta. Angle TUR is equal to delta. What is this called? The angle of, this is called the angle of deviation. Angle of deviation. Delta is called the angle of deviation. What is the angle of deviation? What is its significance? It determines by how much angle the incident ray is deviated with respect to its original path. Its original path was this, right? This is the original path, the dotted line, but it has been deviated by an angle delta, right? So that determines the angle of deviation. All right. Now, in our next lecture, just now we shall discuss the derivation. We have now, till now we have given you all the introduction for the prism. We are now going to discuss the refraction through the prism, that mathematical portion. All right.